In this video, I'm going to show you how to use Statcrunch for the Chapter 5 content. So we're going to start with probability distribution. So I've already got a probability distribution typed into my var1 and var2 list. I have renamed those x and p of x so that we can keep the random variable separate from the probability. Now in 5.1, we just did summary stats. That was really the only calculation we did with probability distribution. So let me show you how to do a summary stat with this. So I'm going to go to Stat, Calculator, and I'm going to go down to the bottom where it says Custom. I'm going to click Custom. I'm going to put my values in, which is going to be my random variable. So this is going to be my first list. And my weights in, that's going to be my P of X, so my second list. And I'm just going to hit compute. And so when I hit compute, at the bottom, it will tell me the mean and the standard deviation. Now, I can also use this to determine significance. So if I wanted to know, for example, if 1 was a significant number, then I could go down here to where it says P of X and do X is less than, and if I click here just so I can show you, you can change these to different inequalities and to equal. But if I want to check this for significance, so if I was asked the question, is 1 a significantly low number, then I could find the probabilities that X is less than or equal to 1, compute, and that gives me a probability of 0.168. So I would know that that's not significant because that probability would need to be less than or equal to 0.05. Similarly, we could do that to any value on the upper side to see if it was significantly high. So let's say, for example, the question was, is 3 a significantly high number? Then I would change this inequality to greater than or equal to. I would type in 3 and compute, and that's definitely not significant since it's not less than or equal to 0.05. The next thing I'm going to show you in Statcrunch is the binomial probability calculator. And so this is an example, I believe this is example 2 from your notes. Given that there is a 0.05 probability that a randomly selected adult smartphone owner is cashless, find the following probabilities. Now, I didn't go through all of these probabilities in your notes, but I am going to show you how to do this in Statcrunch. So you really have to read these questions carefully so that you will understand what kind of inequality or symbol that you're going to use. Let's go to Statcrunch. So in Statcrunch, I'm going to go to Stat, Calculator, and then I'm going to go to Binomial. So this is my binomial distribution calculator. At the bottom, I'm going to put in my number of trials, which in this case is still 10, my probability of success, which is 0.05, and then I can start looking at different probabilities. So that first question was find the probability that 0 are cashless. So I would change this to an equal, type in 0, and compute. And it gives me a probability of 0.599 if I round to 3 decimal places. The next question was find the probability that exactly 2 are cashless. So I'm just going to change 0 to 2 and compute again. That gives me a probability of 0.0746 rounded to 3 significant digits. Now, the next question was find the probability that more than 8 are cashless. So if I'm looking at more than 8, then I'm not including 8. So I want the sum of 9 and 10. So I can change my symbol to greater than, and I can do 8 and compute, and that gives me a probability of 1.865. Now this E means scientific notation, so this would be 1.8, or I would round that to 1.9, times 10 to the negative 11th power. So what is after e is the exponent on the 10 when you convert this to scientific notation. So you could type that question in just like that, or you could do a greater than or equal to and make that a 9. So you'll see that it gives you the same probability. Now my next question is find the probability that less than 4 are cashless. So I can do less than 4, compute, and that gives me a probability of 0.999 rounded to 3 significant digits. Or I could do less than or equal to, because in that wording 4 is not included. I could do less than or equal to 3. The next question was the probability that no more than 2 are cashless. And so when you are using the phrase no more than 2, that means you want to add the probability 0, 1, and 2. So I can do less than or equal to 2 and compute, and that probability is 0.988. Our last question was find the probability that at least 7 are cashless. So at least means 7 or more. So I would do greater than or equal to 7, compute, and that probability is looks like there's 7 zeros there, so 7 zeros and then an 8. And so that would be a very small probability, very unlikely, but that is greater than or equal to 7.